Hello and welcome back to this channel once again. In today's video, we are going to look at simultaneous linear equations in two variables. Simultaneous equations are a number of equations which are true at the same time, and there are a number of ways in solving simultaneous equations. Now in this video, we are going to discuss two of them. We are going to learn how to solve two equations simultaneously using the method of elimination and also using the method of substitution. Now in the next section, what we are going to do is we are going to consider this example where we are going to use each of the two methods to solve these two linear equations simultaneously. So let's begin with the method of elimination. So we are to solve these equations simultaneously. We have the first equation to be 2x plus 5y equals 11, and the second equation, that is 3x plus 4y equals 10. So we are going to use the method of elimination. So we have the first equation to be 2x plus 5y equals 11. Let's call this equation 1. And then we have 3x plus 4y equals 10. Let's call this equation 2. So the first thing to do when solving simultaneous equations using the method of elimination is to consider one of the variables to eliminate. So assuming that we want to eliminate the variable x, we need to make sure that the coefficient of x for the two equations are the same. Now for equation 1, the coefficient of x is 2. For equation 2, the coefficient of x is 3. Now, since the coefficient of x for both equations are not the same, then we need to multiply equation 1 and equation 2 by a value such that the coefficient of x for both equations will be the same. So if we should multiply equation 1 by 3, then 3 times 2x will be 6x. And then if you should multiply equation 2 by 2, then 2 times 3x will also be 6x. In this case, we can do away with the variable x. So we say that multiply equation 1 by 3 and equation 2 by 2. So for equation 1, we are going to multiply by 3. So we have 3 times 2x plus 5y equals 11. This becomes 6x plus 15y equals 33. Let's call this equation 3. And then for equation 2, we are going to multiply by 2. So 2 times 3x plus 4y equals 10. This also becomes 6x plus 8y equals 20. Let's call this equation 4. Now the coefficient of x in each of the equations is 6. So we can subtract one equation from the other. So we say that equation 3 minus equation 4. We are going to subtract equation 4 from equation 3. So equation 3 is 6x plus 15y equals 33. Minus equation 4, we have 6x plus 8y equals 20. So let's do the subtraction. 6x minus 6x is 0. 15y minus 8y is 7y. 33 minus 20 is 13. Therefore, we have 7y equals 13. We divide through by 7, and then we have the value of y to be 13 over 7. So this is the value of y. Now we can put y equals 13 over 7 into any of the equations. So let's say put y into equation 1. So equation 1, we have 2x plus 5y. Now in place of y, we are going to put 13 over 7. equals 11. So this time we are going to find the value of x. Now we have a fraction here. We have the denominator to be 7. So we can multiply each of the terms in this equation by 7 so that we can do away with the fraction. So this becomes 7 times 2x plus 7 times, we have 5 times 13 over 7 equals 7 times 11. 7 times 2x is 14x. 7 cancels out 7. 5 times 13 is 65 equals 7 times 7 is 77. So we transpose 65 to the right hand side. We have 14x equals 77 minus 65. 7 minus 5 is 2. 1 minus 6 is 1. So that is 12. And then we divide through by 14. And then we have x to be equal to 2 goes here 6 times. 2 goes here 7 times. So the value of x is 6 over 7. Therefore, x is equal to 6 over 7. And then y is equal to 13 over 7. So this is how to solve two linear equations simultaneously using the method of elimination. Now let's do same for the method of substitution. So now let's solve these two linear equations simultaneously using the method of substitution. So our first equation is 2x plus 5y equals 11. And then our second equation is 3x plus 4y equals 10. So using the method of substitution. Using the method of substitution. Basically, we are going to make one of the variables the subject from any of the two equations. And then we can substitute that into the other equation. So for instance, if we are going to make x the subject from equation 1, then we are going to put x into equation 2. So the first step is make x the subject from equation 1. We are going to transpose 5y to the right hand side. So 2x equals 11 minus 5y. And then we divide through by 2 so that x is equal to 11 minus 5y divided by 2. Now let's call this equation 3. In the next step, we are going to put equation 3 into equation 2 because equation 3 is coming from equation 1. So we can't put equation 3 back into equation 1. We need to put it in the other equation, that is equation 2. So putting equation 3 into equation 2, we have 3x. So in place of x, we substitute 11 minus 5y divided by 2. And then plus 4y equals 10. Now since we have the denominator to be 2, we have a fraction. So we need to multiply each of the terms of this equation by 2 so that we can do away with the fraction. So this becomes 2 times 3 times 11 minus 5y divided by 2 plus 2 times 4y equals 2 times 10. So 2 cancels out 2. We are left with 3 times 11 minus 5y plus 8y equals 20. So this becomes 33 minus 15y plus 8y equals 20. Negative 15 plus 8 is negative 7. So 33 minus 7y equals 20. We transpose negative 7y to the right hand side and then 20 to the left hand side. So we have 33 minus 20 equals 7y. This becomes 13 equals 7y. We divide through by 7 and then we have y to be equal to 13 over 7. Now we can put y equals 13 over 7 into any of the equations. So let's say into equation 1. So equation 1, we have 2 times x plus 5 times y is 13 over 7 equals 11. So we multiply each of the terms by 7 to do away with the fraction. So we have 7 times 2x plus 7 times 5 times 13 over 7 equals 7 times 11. So this cancels out this. We have 14x plus 65 equals 77. We transpose this to the right hand side. This becomes 14x equals 77 minus 65, and this is equal to 12. We divide through by 14, also by 14, and then we have x to be equal to 2 goes here 6 times, here 7 times. We have 6 over 7. Therefore, we have x to be 6 over 7, and then y to be 13 over 7. So now let's solve an example involving fractions. Question 2. Solve 3 over 4x plus 2 over 3y equals 5, and then 1 over 2x plus 3y equals 11 simultaneously. So we can either use any of the two methods, the method of elimination, or better still, the method of substitution. However, for this question, I'm going to use the method of substitution. So we have the first equation to be 3 over 4x plus 2 over 3y equals 5. This is equation 1. And then we have 1 over 2x plus 3y equals 11. This is equation 2. Now we have to make one of the variables the subject from any of the two equations. So make x the subject from equation 1. So from equation 1, we have two fractions. We have 3 over 4 and then 2 over 3. Now the LCM between 4 and 3 is 12. So we are going to multiply each of the terms by 12. So we have 12 times 3 over 4x plus 12 times 2 over 3y equals 5 times 12. 4 goes here once, 4 goes here 3 times. So that is 9x plus 3 goes here once, 3 goes here 4 times. So 4 times 2 is 8. So that is 8y equals 5 times 12 is 60. So since we want to make x the subject, we transpose 8y to the right hand side. So we have 9x equals 60 minus 8y, and then we divide through by 9. Therefore, we have x to be equal to 60 minus 8y divided by 9. Let's call this equation 3. Now we are going to put equation 3 into equation 2. So for equation 2, we have 1 over 2 times x. Here we have x to be 60 minus 8y over 9, and then plus 3y equals 11. Now we can multiply across, that is 1 over 2 across. So this becomes 60 minus 8y divided by 2 times 9 is 18, plus 3y equals 11. Now let's add these two fractions. The LCM between 18 and 1 is 18. 18 divided by 18 is 1. 1 times 60 minus 8y is still 60 minus 8y. 18 divided by 1 is 18. 18 times 3 is 54. So 54y equals 11. At this point, we can cross multiply. So we have 60. Negative 8y plus 54y is 46y equals 18 times 11 is 198. So we transpose 60 to the right hand side. We have 46y equals 198 minus 60, and this becomes 138. So we divide through by 46, and then we have y to be equal to 3. So the value of y is 3. Now let's put y equals 3 into equation 3. Let's put that into equation 3. We can put it in any of the equations. However, equation 3 looks a bit simpler. So let's put that into equation 3. So we have x equals 60 minus 8 times 3 divided by 9. So this becomes 60 minus 8 times 3 is 24 divided by 9. 60 minus 24 is 36. And then 36 divided by 9 is 4. Therefore, x is equal to 4, y is equal to 3. So for the third example, or the third question, we have a linear equation as well as an exponential equation. Now, how do we solve these two equations simultaneously? Let's do this together. We have the first equation to be 2x plus 6y equals 10. Let's call this equation 1. And then we have 3 exponent x minus 2y equals 1 over 27. Let's call this equation 2. Now, to solve these equations simultaneously, we need to resolve equation 2, that is the exponential equation, into a linear equation. So from indices and then from equation 2, we have 3x minus 2y equals 1 over 27. According to indices, 1 over 27 is the same as 27 exponent negative 1. Now 27 is a multiple of 3. So 3 times what number will give you 27? 3 times 3 times 3 is 27, which is the same as 3 exponent 3. However, because of the negative 1, we multiply negative 1 by the exponent 3, which gives us negative 3. So 27 exponent negative 1 is the same as 3 exponent negative 3. Therefore, since we have the same base, which is 3, we can compare their exponents. So we have x minus 2y equals negative 3. Let's call this equation 3. So we are going to solve equation 1 and equation 3 simultaneously. So we can make x the subject from equation 3. We are going to make x the subject from equation 3 and substitute that into equation 1. So from equation 3, we transpose negative 2y to the right hand side. So we have x equals negative 3 plus 2y. This becomes equation 4, and then we put equation 4 into equation 1. So for equation 1, we have 2 times x. X is negative 3 plus 2y plus 6y equals 10. Let's multiply 2 across. 2 times negative 3, we have negative 6. 2 times 2y is 4y plus 6y equals 10. 4y plus 4y is 10y. We transpose negative 6 to the right hand side, it becomes plus 6. And this is equal to 16. So we have 10y equals 16. We divide through by 10. and then we have y to be equal to 16 over 10. 2 goes here 8 times, 2 goes here 5 times. Therefore, y is equal to 8 over 5. Y is equal to 8 over 5. Now we put y equals 8 over 5 into equation 4. So that is x equals negative 3 plus 2 times 8 over 5. This becomes negative 3 plus 2 times 8 is 16 divided by 5. Let's find the LCM between 5 and 1. So that is 5. 5 divided by 1 is 5 times negative 3 is negative 15. 5 divided by 5 is 1. 1 times 16 is 16. Negative 15 plus 16 is 1. So 1 over 5. Therefore, x is equal to 1 over 5. So we have x equals 1 over 5, y equals 8 over 5. So that's it for today's video. Thanks for watching. Do well to subscribe to this channel. Bye bye.